Hello and welcome. Today, we are going to tackle a core concept in chromatography, the capacity factor. It's also known as the retention factor and is represented by K, or K prime. This simple number is incredibly powerful because it tells us how strongly a compound is retained by the stationary phase. Knowing this is key to developing and troubleshooting any separation method. So, let's get right into how to calculate it and what it means for your results. First, let's look at the formula and its components. The equation is K equals TR/Tm. It looks simple, and it is. The first term, Tr, stands for retention time. This is the total time it takes for your compound of interest to travel from the injector, through the column, and to the detector. You find this by looking at the peak maximum on your chromatogram. The second term, Tm, is the void time, sometimes called the dead time. This is the time it takes for a non-retained compound to pass through the column. Essentially, it's the time any compound spends in the mobile phase. Now, let's walk through a practical example to make it crystal clear. Imagine you've run a sample and your chromatogram shows a void time, Tm, of 2 minutes. The peak for your analyte, its retention time, Tr, appears at 8 minutes. We can plug these values directly into our formula. So, K equals 8 minutes 2 minutes / 2 minutes. The calculation in the parenthesis, Tr/Tm, gives us 6 minutes. This is called the adjusted retention time and it represents the time the analyte was actually interacting with the stationary phase. We then divide that 6 minutes by the void time of 2 minutes, which gives us a final capacity factor of 3. But what does a K of 3 actually signify? It's a ratio that tells us our analyte spent 3 times longer in the stationary phase than it did in the mobile phase. This is why the capacity factor is so useful. Ideally, you want your K to be in a good range, typically between 2 and 10 for most applications. If your K is too low, say less than 2, it means your compound isn't being retained enough and it elutes too quickly, which can result in poor resolution from other compounds. If the K is too high, perhaps over 10, it means the compound is stuck on the column for too long. This results in long analysis times, wasted solvent, and broader peaks, which can reduce the quality of your data. By calculating K, you get a quick diagnostic tool to assess your separation's efficiency. And that's really all there is to it. You now have the knowledge to calculate and interpret one of the most fundamental parameters in chromatography. Thank you so much for watching this tutorial. If you found this video helpful and easy to understand, please give it a like and consider subscribing to the channel for more content like this. Make sure to hit the notification bell so you are the first to know when a new video is posted. We'll see you in the next one.